Okay, in this video, I want to go over another example of function transformation using the exponential function e to the x. So we have these four transformations right here, and using the order of operations, we are going to come up with the functions that represent all of these four transformations in the same order from left to right. So we're going to start with capital P, which is parentheses, and we are going to have something inside parentheses with the x because we are translating the graph of this exponential function e to the x to the left by 2 units. So inside this parentheses, we are going to have x plus 2. And that's parentheses done. Exponent, well, we're already taking care of this exponent for the e function, but I don't think we are going to have any other exponent on top of this whole thing, so we're good on that. But we are going to have multiplication because we are reflecting the graph of the original exponential function about the y-axis. So we have to multiply this exponent by the negative sign. So that's 2 transformations done. And we are going to have another multiplications by a factor of 3 because we are also vertically stretching this function by a factor of 3. So we take this whole thing and we multiply that by 3. And lastly, we are also translating this whole function up by 3 units. So we are going to take this whole thing and just add 3 to it. So the function that represents all of these 4 transformations is the one in the box right here. So how do we graph it? Well, we always start graphing with the parent function e to the x. So recall that on the graph of e to the x, from left to right is an increasing function that passes through that point. It's going to keep going like that. And of course, on the other end, it approaches the x-axis but never touches it. Now, the first transformation that we are going to graph is, as in the same order Pam does, the left translation by 2 units. So we take this whole thing, which is e to the x, I should say. This is e to the x. Hopefully you guys can see that. And we just have to shift this whole graph over by 2 units. So this point would end up right here. And the graph in the blue is going to look similar to the one in the pencil. So this is e raised to the x plus 2. Now the next transformation we have to do is reflecting across the y-axis. So we take the most recent graph in the blue and we just create a horizontal mirror image of the most recent graph in the blue. So this end would end up over here and this end would end up over here. And this point is still going to stay there. So it's probably going to look something like in the black here. Let's say, oops, oh, that was bad. Something like that and something like that. Okay. And guys, this is a rough sketch, so I do apologize if my graph come out bad. But the one in black here is e raised to the negative of x plus 2. The next transformation that we have to graph is vertical stretch by a factor of 3. Well, we take the most recent graph in the black and we just vertically stretch it out. So it's going to look taller than the one in the black. And it's probably going to look something like this. So if we take this and we stretch it, then the graph in the red is probably not going to pass through this same point. It's probably going to pass through somewhere. Something like this. It'll look like that, okay. So yeah, so the one in red is 3 times e raised to the negative of x plus 2. And of course, note that even though it looks like the graph in the red is touching the x-axis, but it's not touching. It's actually just getting extremely close to the x-axis, but it's not supposed to be touching that. So, rough sketch. It's difficult to draw, especially on a blank paper. But anyway, the last transformation is translating up by 3 units. So we take the most recent graph in the red and we just move everything up by 3. So let's say, like I would say, let's just say take this point. Let's just say there's a point on here because I try to eyeball it. So let's just say there's that point on the most recent graph red. And let's just move it up by 3. So 1, 2, 3, somewhere right there. I don't know. Rough sketch, like I said. And we're just gonna sketch another version of the red. So something like that. And the one in green is the function in the box. So yeah, that is how we graph each transformation of exponential function e to the x, guys.